I am Chris Marki. I'm the CEO of Marki Microwave. I'll give you a little bit of a background in terms of who we are, what we do, and how we fit into the ecosystem of quantum right now. So Marki is celebrating our 30-year anniversary this year. We were founded in 1991, so we have a pretty deep heritage into the RF and microwave components industry. My dad actually started in 1971, so that's a 50-year tenure. I started about 13 or 14 years ago, and we started out as a mixer company primarily. And over the last 10 years, we've been expanding into many other product categories across many different types of platforms. Our primary markets that we serve are test and measurement and aerospace and defense. And quantum has been one of those researchy areas that's obviously, as everybody knows, is turning into an actual industry. And so I think that our lineage dates back to customers buying our IQ mixers and using those for quantum qubit control. And since then, we've been collaborating with most of the major players in terms of what other component problems they have in their boards. And as I think the theme of today will be, how do you make them smaller? How do you scale? How do you get from a one-off physics-based, physics level research demo to an actual industrial product? And so I think that's kind of where we're at today, and we're at that inflection point with how do you justify the investment. Historically, we've been a broadband high linearity type company, and that was certainly what aerospace and test and measurement were asking for. The quantum requirements are slightly different, and I do think that changes a bit of our sort of a R&D profile and interest level. So in terms of capabilities, we are vertically integrated. We have significant amounts of manufacturing capability in-house in our Morgan Hill facility in California. We have something like 60,000 square feet now. We just moved into a brand new, larger building. We have manual assembly, doing hybrid assembly, solder assembly. We have automated assembly in-house, and we also go to CMs for that. And then we also do microelectronics assembly. And significant numbers of our products these days are now mimic semiconductors. So we're also a fabless IC company. I think where we fit in the ecosystem, or what makes us interesting, particularly for quantum right now, is that we have a very good understanding of both the call it one-off connectorized type modules that I think researchers tend to begin with when they're doing baseline experiments, but we also have experience ramping to hundreds of thousands of units through things like miniaturization, surface mounting, MMIC assembly, that sort of thing. And we know we have a very good understanding of all the different manufacturing techniques available to us today. And I think that's generally when we speak to quantum companies, that's what we tend to focus on now, is how do you pivot from these very expensive, larger connectorized modules to something that's more of a die level chip in package solution. We sell numerous different components that fall into the quantum framework. I think namely we're best known for the IQ mixers, but we also sell various filtering components. It was just mentioned about the IR filters. We've been doing that for over a decade, actually. We sell a lot of products that are used at room temperature, like balance, mixers, filters. And we also have capability and are working on other things such as LNAs, attenuators, and many other products, especially that could be built for scale using semiconductor capability. So to summarize, we are an American company. Most of what we do is fabricated and assembled here. And we have knowledge of connectorized, hybrid, and MMIC solutions. And currently we are partnering with many of the players in the industry selling mixers and other things. And we're seeking, relationships with companies who are willing to, partner to help expand these products to put them into larger systems. Because I think right now, and the theme of today will be, how do you justify the investment? And so I think that's where we're at today.
Thanks, Chris. So really, Marki's had a long track record in RF and scaling RF, miniaturizing RF, but you're just starting now. Is it correct? You're just starting now to get into the cryo realm, but you're really, to justify it, you're looking for partners. Is that what you're saying?
I think what I'm saying is that, well, we can expand on this, I think, in the Q&A, but I think what I'm saying is many of the things we do today already could be used at scale. The
Right.
biggest questions that tend to come up are, how does it perform at cold?
Yeah.
Will it change its spec? Is it going to be reliable? Well, what happens when we have 1,000 qubits instead of 10? And to date, I think, and my understanding from the physics community is that when they find a component that works, they tend to tell each other, and then they all start adopting the same component. And I don't know if there's a set of specifications. Well, there do not currently exist a set of specifications that I can qualify my part to sort of guarantee to the world that the part is suitable for this application. Unlike in our aerospace and military customers, they all agree that mil specs are the standard by which they will accept the suitability of a part. There's no such thing of that in cryo, and I've been I guess banging the table to the quantum community for some time that we really need to agree on a set of specifications, and primarily I would say they're mechanical specifications, like, you know, will the thing break, or what materials are acceptable.
So let's definitely get into that more in the panel. I have a couple of questions that go right to the point of that, right?
Sure.
So thank you.